Welcome guys. In this video, we are going to learn about elastic load balancer. Before we learn about elastic load balancer, we need to know about what is a load balancing. So load balancing is a technique that we use to say distribute the workload across multiple computing resources. For example, we have multiple computers, or we have a computer cluster, we have network links, or we have central processing units or disk drives. So it is simply a scenario where you use something to help reduce the load. How? By distributing that load. So here, let us just get a quick idea about it. Suppose we have this application server. Now this application server is getting some load. Say there are some say 1000 users coming every hour, and the server is performing absolutely well. Now what if we increase the users? Say now instead of 1000 users we are getting 10,000 users. The system is not designed to bear this load. The server is not designed to bear this load. Now what would happen? The server would stop responding. It may crash. So this is one of the things that usually happens with all the servers whenever they go beyond the stipulated load limit. Here the limit has been crossed. For example, the limit that was say this was designed to run for 4000 users. Now 1000 is okay for 4000 users, say capacity of server, but whenever there are 10,000 users, in that case we won't be able to run this server well. This will fail. Now in that case what we can do is we can use multiple servers. So what if we use multiple servers? Say I use multiple servers, say server 1, server 2 and server 3. Now, what would happen? Consider a scenario, suppose the load balancer is not here. Question would come up that how would I be able to distribute the traffic? Either all of my traffic would go to application server 1, either all of my traffic would go to application server 2, or either my say traffic will go completely to application server 3. Now, in all these three cases, or in this case, in all these cases, the problem is that again the load will be bared by only and only one server. So all of these, one of say one second, yellow won't be visible to you guys. So here only one server is busy. Other are free. This happens. So now question is, how would you be able to handle a situation where you would want to have the users handled and in a much clearer way? So here what we will do is we will make use of a load balancer, this thing. With the help of this thing, what would happen is the users will come to a load balancer. Load balancer will decide which request to forward, which it has to forward to which server. Now the thing is, all these servers are replicated. So replica 1, replica 2 and replica 3. So all these three servers are serving the same application. Now the benefit is that load balancer will decide whether the request has to go to the first server or the second one or the third one. Now what is the benefit here? The benefit is that the situation where we were only able to handle say a limited number of users, for example, say we were able to bear 4000 users in app server 1. Server 2 also used to bear 4000 users and server 3 also used to bear 4000 users. We were facing 10,000 users. What we can do is we can distribute those users. Suppose first 3000 users, say 3500 users are sent here. Next batch of 3500 users are sent here. The last batch of 3000 users are sent here. Application is performing well. Users are getting to see a better application, and the thing is Our servers are not getting flooded. None of our application servers are getting flooded. Another scenario, what if due to some physical failures, due to some issues, one of the server gets down? Suppose this server gets down. Which one? Say my this server. This is completely down. This is not working absolutely. So what will we be able to do in this particular case? Suppose it is not at all working. Now here we have application server 2 and we have application server 3. So the traffic will be routed to these directly. The first packet will be routed to application server 1. If it doesn't work, the application, say load balancer, will automatically divert the traffic to server 2 and server 3. In this way, what will happen is that we will be getting to see a application which is much more stable. In the backend, what is happening around, the customer does not need to know. That is what we need to know. So we need to balance the application in a way, we need to balance the website in a way, we need to balance the servers load in a way, so that even if one of the servers gets down or two of the servers gets down, the website doesn't get down, right? Here this helps us in managing the application very well. Now suppose first application server went down and we immediately shifted to server 2 and server 3. We got to know that there is a problem in server 1. We rectified the issue, we reconnected it, we restarted it, and it started working absolutely fine. The request that load balancer is distributing will again start, it will start again sending those requests to the server. So we don't have to worry about all the things, that how the things will go around if the server gets down. Everything will be done intelligently. Here, this was about the load balancing concept. So with this, we get to understand one thing, that is load balancing aims to optimize the resource usage, maximize the throughput, minimize the response time, and avoid overload of any kind of single resource. Right? This is done. Now, the next thing, that is elastic load balancer. So what is elastic load balancer? Now, elastic load balancer is the Amazon's flavor of load balancing. It is used for the load balancing of services that AWS provides. For example, the services are, say, EC2, we have containers, we have IP addresses, and we have Lambda functions. So we can have multiple EC2 instances, we can have multiple containers running, or we have multiple IP addresses, or we can have multiple Lambda functions. We just want the load to be balanced between these. So here, coming back to this image, let us just consider these as, say, EC2 instances. So here, this is not application server 1, this is not application server 2, this is not application server 3. Instead, what this is EC2 instance. So EC2 instance 1, this is EC2 2, and this is EC2 3. So here the distribution of load will be the same way the load balancer does. It will be sending requests to EC2 server 1, then it will be sending requests to server 2, and it will be sending requests to server 3. All these things will be done automatically. For example, containers. Yes, containers will also be done the same way. Container 1, container 2, and container 3. So this can be done. This is not the issue that we won't be able to distribute the load. It's just that we need to have multiple things running so that the load can be distributed very easily. So here, this is how, say, this load balancing concept works, and you can, say, have these things balanced easily. Now the next thing is, say, where we can use ELB, where we can, what is the use case scenario for this? So here, if you notice something, it can handle the varying load of your application traffic in a single availability zone or multiple availability zones. This means that ELB. ELB is region specific. Suppose I'm in Mumbai, so it has three AZs, A to say C. All the traffic will be distributed from say A to A only, B to B only, or C to C only, or maybe from A to A and A to B and A to C, and so on. So here we have that flexibility within the region. So within region, we can route traffic, or better word, distribute traffic. So this helps us in managing the things in a way, managing the servers in a way so that we have the minimum downtime, the lowest downtime here. So this was for this video. If you have any queries, you can feel free to ask in comments. Thank you.